Pumps used to keep liquids flowing through plant piping are positive displacement pumps. They use different types of internal components to push or positively displace controlled amounts of liquid through the pump. One type of positive displacement pump that's commonly used in industrial plants is a rotary pump. Rotary pumps use the rotating motion of components like screws, gears, and vanes to move process liquid. Since rotary pumps are common to many industrial applications, it's important for operators to understand how they work. Like other types of positive displacement pumps, rotary pumps are commonly named according to the type of component that moves liquid. For example, some rotary pumps are called screw pumps because they use screw-like components to move liquid. This is one type of screw pump called a single screw or progressive cavity pump. It contains a single screw that's located inside a casing. This end of the screw is normally connected to a driver. As the pump operates, process liquid is drawn into the pump through the suction port. As the screw rotates, cavities form between the casing and the screw. These cavities move or progress toward the discharge of the pump, carrying the process liquid along. When the liquid reaches the discharge, it's forced out of the pump. Progressive cavity pumps have a few unique characteristics. For example, they can move extremely viscous liquids, like sludges and gels, without clogging. Now, not all screw pumps use a single internal screw. This is a two-screw pump. One of the screws is attached to a shaft that's coupled to the pump's driver. This screw is known as the power or driver screw. The other screw is often referred to as the idler screw. In this pump, power is transmitted from the driver screw to the idler screw through a set of timing gears. During operation, process liquid enters the suction of the pump and is directed toward both ends of the casing. As the screws rotate, the liquid becomes trapped between the casing and the screws. The liquid is moved from both ends of the pump toward the center, which is also the discharge of the pump. The force that's exerted by the screws pushes the liquid out of the pump and through the discharge piping. Now that we've seen how a couple of screw pumps work, let's stop so you can check your understanding. Select the arrow to the suction on this screw pump. Many rotary pumps use gears or lobes to move process liquid. Like other rotary pumps, gear pumps and lobe pumps can be used to move viscous liquids, such as heavy fuel oils and tars. Let's look at gear pumps first. One of the more common types of gear pumps is an external gear pump. The external gear pump shown in this illustration consists of a casing with a suction port, a discharge port, and two gears located inside the casing. One gear is rotated by the pump's driver. This gear is often referred to as a power or driver gear. The other gear moves because its teeth are meshed with the teeth of the driver gear. It's called the idler gear. During operation, liquid enters the pump through the suction port. As the gears turn, the liquid is trapped in the spaces between the casing and the gear teeth and moved along the casing. When it reaches the discharge port, it's forced out of the pump. On this type of pump, each space between the gear teeth positively displaces a given amount of liquid. So on each revolution that the gears make, a specific amount of liquid is pumped. Can the pump shown here be described as being a gear pump? This is an internal gear pump. This pump has a casing with a suction port and a discharge port. Inside the casing are a crescent-shaped spacer and two gears. The spacer prevents liquid from flowing from the discharge back to the suction of the pump. On this pump, the outside gear is rotated by the pump's driver, so it's the power or driver gear. The inside gear moves because its teeth are meshed with the teeth of the driver gear, so it's the idler gear. But keep in mind that on some internal gear pumps, the inside gear is the driver and the outside gear is the idler. When this pump operates, there are two separate liquid flow paths inside the pump. One flow path is in the spaces between the inside gear and the crescent-shaped spacer. The second flow path is in the spaces between the outside gear, the spacer, and the casing. During operation, Liquid is drawn through the suction and into the spaces formed as the gears unmesh. As the gears continue to rotate, the liquid moves into the spaces between the inside gear and the spacer. These liquid-filled spaces move with the inside gear until they reach the discharge of the pump. There, the liquid is forced out of the spaces as the inside and outside gears mesh together. The liquid that flows in the other flow path is drawn in from the suction of the pump and into the spaces formed by the unmeshing of the two gears. As the outside gear rotates, some of the liquid is trapped in the spaces formed between the gear teeth, the spacer, and the casing. These liquid-filled spaces move with the outside gear until they reach the discharge of the pump. There, the liquid is forced out of the spaces as the inside and outside gears mesh together.